Okay, everyone, let's see. Okay. Now, we know that, first of all, I loaded the quiz and Candace put a 0 in for everyone. Right, so I took that out this morning. I don't know why Candace, I must have, when I loaded it in, it must have had a date set because I copied it from another course. And it must have been past the deadline, so I threw a 0 in for everybody. And when I changed the date, it doesn't take the zeros out. So I took all the zeros out this morning. Then we know that this take-home quiz, I just call this a take-home quiz. This should be due tonight at 11:55 p.m. I know a bunch of you have already taken it. Again, the questions are exactly the same, but the A, B, C, D might be mixed up. So this and OWL is due tonight at 11:55. Remember, you still need to submit from OWL. So once you're done with OWL, you still need to click submit and it'll throw it in Canvas. I think a bunch of people have got that done too. So, and then the third thing is, I got an email from contact tracing, so somebody was in here positive for 3 days. So you're going to get an email from contact tracing. What I did is I take my attendance sheet with the map and I just scan it and I sent it to them last night. So that's how that works. That's why we take attendance. And where is that attendance sheet? Get that thing rolling around. So you have to put in for, yes, yeah, I didn't put it around Monday. So where's that sheet? Okay, try to move that, make sure that thing moves around, moves around, moves around. That's why we do the attendance sheet. So if you get an email, then you'll know why. You were in that territory or region, I guess. So that's how that works. It looks like the B2 variant of Omicron is going around. It's 4% of the US cases right now. And so there is a variant of Omicron that is the one article I read was 1.5 more contagious than the original Omicron. So I don't know if this, but hopefully this should be the last. We should be able to get to summer like we did last summer. And the whole entire state of Wisconsin was below 200 cases last summer. Below 200 cases for the entire state. Yes.
Well, I saw like something on National Geographic saying something about a stealth variant.
A stealth variant, there's going to be variants all the time.
Well, yeah.
Hundreds and hundreds and hundreds, but a stealth variant would be defined probably as something that the vaccines don't work on. But yeah, I don't know. Hopefully maybe this is it. So please wear a mask in here. If you want to go down to the pickle in the weekend with no mask on and dance on the bar and spit and scream, that's up to you. But you have others in here that work as CNAs taking care of elderlies. They have elderly grandparents and stuff like that. They take it very seriously. So what you do outside is fine, but please, when you come to class, wear a mask, respect others that are in here that do have delicate jobs and things like that. So, okay. So we know you're just going to input the answers for this, right? All right. Then I loaded the next 2 quizzes. And again, we're going to do the same thing then. You're just going to work on these. And right now, this chapter 2 quiz, you could probably do the first maybe 15 on here. So just work on these. We're going to enter the answers at the deadline again. Okay. Now, what's the test questions going to look like? Somewhat similar to these quiz questions. Or I might pull some things from out. It's going to be tough because we don't have 50 minutes to do a test. Last semester, I had an hour and 15-minute class. So I'm going to have to pull just certain questions. And it's kind of a double-edged, so you get less questions, but obviously they're going to be worth more points, right? So a 40-question test at 2.5 points each versus a 20-question test at 5 points each. So, okay. Last time we talked about isotopes. And at the end, I talked about this real quick, the isotopes of uranium and this concept of critical mass. So you have to slam the two critical masses together to get the chain reaction to take place. So, and I mentioned all of this takes place in what is called the Manhattan Project. And let me go back and make sure I'm sharing the correct screen. And where do I have? Let's see if it can go. So this is all the secret camps to build the bomb. And you have to realize, we know that Germany is doing the same thing. The race is on. Whoever gets this thing is going to win everything. Absolutely everything. These are all the secret camps in the US with one thing to do, and that's to successfully find uranium and successfully separate out the 0.72% and you enrich it. It's all about enriching the uranium. The biggest one is Oak Ridge, Tennessee. So these are all the people coming to work in Oak Ridge, Tennessee. This is the Y12 uranium enrichment facility. 82,000 people are working here. This is only one camp. This lady right here, I believe her name is Gladys Owens. Yes, she didn't even, she recognized herself 50 years later, sitting there all day. This is an enrichment facility. So it's, and this is all in Wikipedia right here. This is the first, you can see little man here, fat boy back here. This is the mechanism to slam the two subcritical masses together to get a chain reaction. So you have thousands and thousands and thousands. We drop one bomb, one test bomb from a tower, and that's it. So, I mean, there's stuff like this all over the place. Signs like this. Basically, keep your mouth shut. Don't talk to your neighbors because you can't trust your neighbors. I mean, there's just, it's just an incredible, incredible time in history. Okay. Now, here, and there's a link in here. Here is a table of naturally occurring isotopes. So we talked about isotopes last time. I'm going to zoom in on this. So if we just take boron, there are two isotopes of boron, boron 10, boron 11. What's the difference? One neutron, right? One neutron. But in nature, 19.9% of the boron has atomic or mass number 10. And if you add up all the protons, neutrons, and electrons, we get an atomic mass of 10.012937. If it's boron 11, 80.1% of that is found in nature, and it's 11.009305. So some elements are 100%. There is no isotopes found in nature. So if we look at phosphorus, the abundance is 100%. So if you look at your periodic table for phosphorus, grab your periodic table for phosphorus. The atomic weight for phosphorus is given on the periodic table, number 15, as this number, 30.973. Now, if you look at chlorine, chlorine has two naturally occurring isotopes, chlorine 35, chlorine 37. So what you see on the periodic tables, what we're going to talk about is a weighted average of these two isotopes. And on the periodic table for number 17 chlorine, the atomic weight is 35.453. So what you see on your periodic table again is a weighted average. And if it's 100%, then that should be the value you see for scandium on your periodic table if it's 100%. Right? It's kind of like this. If you own an apple orchard and 60% of your trees are McIntosh and 40% of your trees are Red Delicious, the size of the apples are going to be different, correct? So somebody says, hey, what's the weight of one of your apples? I don't know. But you can calculate a weighted average and you can give that person one number if you calculate a weighted average. It's kind of like that. Okay, so I'm going to switch over to this document camera and make sure I'm on the right camera here, and it should be this one. So let's see. All right, so last time we filled in this chart of the isotopes. So now let's calculate a weighted average, and I'll have you do this. So here's table 2.2 on page 51 of the textbook. It says a sample of magnesium is found to contain 78.99% magnesium 24. And the entire mass of the atom is 23.9850. I got an extra U in there. This stands for, it should be just AMU. And that is atomic mass unit. Atomic mass unit, AMU. Well, let me go back. One more table. For whatever reason, the text uses the symbol U for AMU. The textbook uses U, I'll use AMU. So I will use AMU, what's it stand for? Atomic mass unit. And one atomic mass unit, 1.66 times 10 to the minus 24 grams. So hopefully you filled this in from your periodic, or from your table. So then 10% of the magnesium is magnesium 25. And the mass is 24.9858 atomic mass unit. And then the last isotope is 11.01% magnesium 26, and the mass is 25.9826. So the question is, what's on the periodic table? And on the periodic table, it's 25.305. So this should be a weighted average. So how do we do a weighted average? Real quickly, let me show you this. Don't write this down. If 60% of your grade is tests, and this is not the case. If 20% is quizzes, and then 20% is OWL, and that's up to 100%, right? So let's say your test average is 90, your quiz average is 80, and your OWL average is 70, which is not going to be the case. What is your final percent when that's weighted? Well, 0.6 times 90, 54. 0.2 times 80, 16. 0.2 times 70, 14. Then we add this up, we get 14.67. Your weighted average is 84. which would be like a B, final grade in the course would be a B, 84%, right? What's most of your grade? Tests. It's right here. It's the weighted average. It's 54 out of the 84 comes from tests, 90%, or excuse me, 60%. So we do the same thing with the isotopes. So and we're going to calculate this right in this box. And here's what this is going to look like. If we take 78.99% as a decimal, we would have 0.7899 times 23.9850. AMU plus 10% magnesium 25. So 10% is going to be 0.100. And that is 24.9858 AMU. And the last one here is 0.1101 times 25.9826. Made that ugly. Your calculator will do that just as it looks. It will do the multiplication and it's going to multiply before it adds. So you should be able to grab your calculator, slam that in. Grab your calculator right now, slam that in. Our limit here, as you do lab today, what's limiting our sig figs is our percentage. So all of these would have 4 sig figs. And if you punch this in, I got 24.3. Oh, I'm gonna do it. I got 24.305, which matches our periodic table, right? Even though we should only have 4 sig figs due to this. Okay. Let's do a little review and check, and then I have an owl question here. So this is how you do a weighted average. Again, your calculator, just the way it looks. This is just a multiplication in there, right? Just a multiplication, and we'll go right in. All right, number 1, which is more abundant? Which is the more abundant isotope of copper? Copper 63 or copper 65? Copper from your periodic table is 63.546. Well, if it was 50-50, it would be right around 64, right? Between 63, well, since it's lower than 64, the most abundant one should be copper 63, right? Yep. An element has 4 isotopes of, so it's X204. It gives us a mass and a percent. A mass and a percent, a mass and a percent. It says identify the element by calculating the atomic weight from this data. All right, let's grab our calculator. Just do it without writing it all down. All you have to do is move your percent to make it a decimal. Move the decimal point to the left two places, right? Grab your calculator, let's see what we get. Did I get this?
Yeah.
Yeah, 207.22, close to 207.22. And that's so 207.2, something close to that. What element we got there? Yeah, we should have 207.2 right here gets us lead, right? So it looks like we've got lead. Now, if I don't like an owl question, or I think it's confusing going forward, you'll see ugly owl. I call it an ugly owl. I'm not calling it a pretty owl, it's an ugly owl because it's an ugly question. And I don't like this question, but this is an owl question. And it says the element antimony has an atomic weight of 122. Well, I wish it would be more accurate. I wish it would give us some decimal points, but so antimony of 122. It consists of two stable isotopes, antimony 121 and antimony 123. Isotope antimony 121 has a mass of 121 AMU and a percent natural abundance of 57.3. Antimony 123 has a percent natural abundance of 42.6. What is the mass of antimony 123? So we have this scenario. We know 121 is, I'll put it right here. We have 0.573% is 121. We know that 42.8% or 0.428 is 123. Right? But it says, what is the mass of 123? X. Equals 122. Now remember, this is a mass number. They matched up perfectly. I just don't like this. I just don't like it. So grab your calculator. Can you solve this? So we need to solve this for X. If you solve this, we're going to get like 123.05 something if you solve it. Like just don't like that question.
So an owl, we put it as a whole number or
Yeah, I'm sure it's gonna be 123 an hour,
okay.
but it's a terrible question. Because it just rounded everything. I don't know. It's just, owl's pretty good, but this is just a question I just shake my head at. All right, let's go to page 5. So periodic table. 1870. Mendeleev was credited with creating the first periodic table of the elements. The periodic law states the properties of the elements are a periodic function of their atomic numbers. The table has 7 horizontal rows called periods and 18 vertical columns called groups or families. Group 1 elements are referred to as alkali metals. So this right here is the alkali metals. Now, so the alkali metals would not include hydrogen. You'd have, because hydrogen is not a metal. Lithium, sodium, potassium, rubidium, cesium. And we should not include francium. Francium only exists for a short amount of time. So the alkali metals here, then group 2 is the alkaline earth metals. Group 2, group 17. Now, here's the problem. And it might even matter in which periodic table. What I have on the screen, check this out, is probably going to be different. Here's group 1A, 2A, 3A, 4A, 5A, and so on. Does that match your periodic table? It does. It's not going to match the textbook periodic table. So the A's and B's can be different. To avoid all that, just use the left number, and that's what I do. I do 1 through 18.
Oh, this one doesn't actually match, I guess, because this says B on here.
Yeah, I thought that one. So this is the old version of that table. So yeah, the one you have, I don't think is, yeah, here it is. So realize, yeah, it doesn't match. So I just use this one because it's just a little bit bigger. It's easier on for the document here. So the 3B, just be careful. I usually, or I will, in every question that I type in, it's going to be 1 through 18. Here's number 18. Be careful in OWL that you might look at, well, OWL is not specific to our textbook either. So be careful, double check which OWL is referring to. Because I don't think it puts everything in parentheses like I do. Okay. So these are the main ones you should know. Alkaline metals, alkaline earth metals, group 17 here. Group 17 is the halogens. And group 18 is noble gases. So we have 18 vertical columns called groups or families, and then, so groups or families are going to be 1 through 18. And then the periods are going to be 1 through 7. All right, so here's a little bit of review. Use periodic table to give the name and symbol for each of the following elements. The noble gas in the same period as germanium. The noble gas, so we're in group 18 in the same period or row as germanium. And germanium is right here. So we should be looking at this row and we're going to intersect at krypton, right? Krypton for that. The alkaline earth metal in the same period as selenium. So alkaline earth metal, I should probably have a capital E there. This is period 2. Excuse me, not period 2, group 2 in the same period as selenium. And selenium is 34, so we go way to the left and we're going to intersect group 2 at calcium. And then C, the halogen in the same period as lithium. So the halogen is group 17 in the same period as lithium. So if we start here, we're going to go over till we intersect group 17, which is a halogen. So we're going to get fluorine. A down here, if we do these for review as well. The alkali metal with 11 protons and a mass number of 23. 11 protons should be sodium, right? And if we did that for A, we'd have sodium 11, 23. Noble gas, 75 neutrons, 54 electrons. It's a neutral atom, so it also has 54 protons, right? And 54 is xenon. What's my mass number? 129, I think. 75 and 54, 129. And C, the isotope with 33 protons and 40 neutrons. 33 protons. What do you get for 33 protons? We get arsenic. And that would be 73 and 33. And D, alkaline earth metal with 88 electrons and 138 neutrons. So 88 looks to be radium. 88 and 88 and 138. How's my mental math? That's 16, 120 for 226. 226. Yes, 226. 226 and 88. Okay. Let's see what we got here. This brings up some pictures I took directly on an owl as well. All right. Ionic versus molecular compounds. A compound that contains ion is held together by ionic bonds ionic bonds is called an ionic compound. These compounds usually contain a metal ion. An example is table salt that has the formula NaCl. For ions, see the pink sheet. So this pink sheet here, everything on this side of the pink sheet has charges. Everything on here is an ion. Okay? Everything on here is an ion. When atoms share rather than transfer, gain or lose electrons, you form a covalent compound that contains covalent bonds. Carbon dioxide is an example. So notice that this starts with a metal ion. Ionic compounds are going to start with a metal ion. Covalent compounds are going to be bold nonmetals, or a bunch of nonmetals. Well, here is a picture I believe I took from owl. So you get an idea of what the owl looks like here. So here's a molecular formula. C2H6O. The name is ethanol. Some of you should back off on the use of ethanol, maybe. Condensed formula. Structural formula. And here's a molecular model. But to review real quick, and this will come up again. If we look at the structural formula, carbon is going to have 4 bonds. So just look at this pattern. If you have carbons, you've got 4 bonds. If you have oxygen, you have 2 bonds. If you have hydrogen, you have 1 bond. That's the way to look at it. And this right here, that's that CH3. Then you could see this right here is CH2. And then the OH. So you can kind of see the pattern. I don't remember how the owl question goes for this, but you can look at it and kind of decipher it like this. They're not complicated questions in owl. It's just having you look at these. Notice it says molecular, not ionic formula. Why? All of these are nonmetals, right? All of those are nonmetals. Then towards the end of the semester, we'll be looking at structures like this when we do Lewis structures and bonding. And this is directly out of OWL. This is kind of universal. Carbon, hydrogen, oxygen, nitrogens, and chlorines. My color on this is not very good because I printed this from my house. Here, I guess at the bottom here, it says a question similar to OWL. So it must be on the next page, page 8. Yeah. So what is the molecular formula of this acid? So you're just adding up the total carbons, right? It starts with carbon. So what is the total carbons we have here? 1 carbon, 2 carbons. It looks like we've got 3 carbons, right? So if we have 3 carbons, I mean, that's not the answer. You're just adding everything up. Then if I use how many hydrogen do we have here? 1, 2, 3, 4, 5, 6, 7. So it looks like we've got the answer already. Looks like, I mean, there's 7 hydrogen there, and it looks like this should be the answer, huh? Just based upon the C3H7. Okay. All right. I want to get started. I'm going to skip ahead just a little bit. We know that we form ions, and I mentioned that. We want to get started with this a little bit today. Grab this in the last amount of time that we have. So this is ionic compounds here. So I do this, and then this matches the other quiz so that when you get to lab, you know what chemicals you should be grabbing. So if we want to write the formula for barium chloride, the symbol for barium is Yeah. Now, we know it's going to be an ion because it's combined with the chloride. Now, some patterns. We know that everything in the alkali metals in group 1 have an ion charge of +1. Gives up 1 electron, right? Everything in group 2, an ion charge of 2. Everything in group 3, an ion charge of 3. Group 4, look at what happens. Titanium, depending upon what it is bonded with, titanium can give up 4 electrons, 3 electrons, or 2 electrons. What it does most often is the bold number on here. Which one's bold? The 4. What vanadium does most often is it gives up 5 electrons. So you have all this positive charge here. When we get over to this side, we start seeing negative charges. This plus and minus for the chlorine, there's only one negative number here. The negative is -1. The rest of these numbers are positive. And these noble gases over here, they don't form compounds. So you don't see ion charges. To make life easier for you, here is an alphabetized pink sheet. So if we go back to titanium, look at titanium on your sheet. And titanium is right here. I underline the bold one, what it is most often. So titanium on your pink sheet, the 4 is underlined because the 4 is bold on your periodic table. Okay. So now, let's go back to this. That's a little bit of review on ions. We have barium chloride. What is chloride? We know that chloride is Cl. What charge does barium take on? +2. What does chloride take on? -1. Now, if barium loses 2 electrons, something's going to take them both. So we need another chloride. You know all of your electrons are accounted for when your total across the top is 0. If you've been taught the crisscross method, I do not like it because you end up reducing. But the formula here then is going to be BaCl2, right? That's going to be our formula. And number 2, aluminum nitride. Aluminum takes on an ion charge of +3. Nitride takes on a charge of -3. So that's it, you're done. That's the formula for aluminum nitride. Now, in number 3, you have tin Roman numeral 4. Tin has more than one positive charge, so the Roman numeral tells you what you have. Oxide's always -2 unless it's a peroxide. So if we have a +4, we need another -2, and we're going to get SnO2 for a formula. Iron 2, Fe+2, nitride -3. Now, if you're just starting out doing this, you do not have enough positive charge. We need another iron. Then we need another nitride. And then we need another iron. So the correct formula would be Fe3N2. For 5 and 6, we use these prefixes in the box. These are covalent compounds. Both of these are nonmetals. So we just use what's in the box. We don't have to worry about charges. Carbon is C. Oxide is O. And the dye is 2. Sulfur is S. Fluoride is F. And hexa is 6. Now, see what you can do. You should be able to finish this page. So before we meet next time, finish this page. You can get started with OWL. You can try some of these, it's all multiple choice. But in this quiz right here, you should be able to do questions 1 through 13. You should try 1 through 13 on this for sure. These take-home quizzes, you can talk to each other on those. They're take-home quizzes, they're a learning tool. Stay out of trouble, don't smoke, vape, or get COVID.